Okay, so looking at this one, guys, is this one continuous or discrete?
Continuous.
It's continuous. Very good. How did you know that? No breaking points in our x's. It's continuing forever. Very good. What did you describe the shape as? I'm loving that. I'm loving that. Some people said absolute value. Awesome. This is absolutely absolute value. Way to go. If you called it a V shape, a sharp V, that would work too for today. Absolute value. Way to remember that. That's awesome. We will be dealing with these more throughout the year. And they're kind of fun. Actually, absolute value graphs are kind of cool once you get into the nitty-gritty of them. Okay, was this increasing or decreasing? We focus on end behavior. Increasing. Very good. What did you put? Just curious. The people that said that they forgot that. Just, what did you put? You put what? Oh, it's okay. You just forgot that one. Okay, I was going to say, if you said, because a lot of people say, well, it's decreasing and then it's increasing, and I can see where you're coming from with that. Yes, you're right. In a sense, it does, but technically, we look at end behavior, so this one's increasing. But yeah. Okay, is this a function? Yes, and you knew that because why? Okay, good. So she said this. It only hits one spot. So that's absolutely correct. Beautiful way to put it. Also, just keep in mind what that means is for every x, there's only one y value. Meaning it doesn't hit a y up here, and it doesn't hit a y down here in that one x spot. Okay, so if we drew a line, it never hits the line twice on the y-axis. So this is definitely a function. And then the x and y intercepts. What are the x-intercepts? Where does it cross the x-axis? -3, just eyeball on this one and 3. Okay. And then how about my y-intercept? Good, -3. How many of you got 100% correct? Awesome. How many of you got just almost all correct? Also awesome. Very good. Okay, guys, let's get started. I want to make sure we have plenty of time. Let's get going so that you have way less homework and maybe not even any depending. Okay, so first of all, let's get out our graphing calculators real quick and make sure we know how to use our calculators to do these things. Now, yes, we absolutely can do it by hand. That's totally fine. You've got to know your stuff, though. I would suggest using a calculator just because in the real world you can, on the ACT you can. It's best to just learn how to use these, okay? Now, if you don't have a graphing calculator, there's people on your desk that do. You're going to need one in the future, so be watching. So let's just type this in. So 2/3 plus 5/2, guys. With adding fractions, you have to have a common denominator, meaning bottom of our fraction has to be the same. So we'd have to go through by hand and manipulate this and change it, get it to be a common denominator, which we should be able to do, but at the same time, let's just use our calculators. So 2/3 plus 5/2. I'm going to show you just quick reminder on those calculators, few little things. Let's practice typing it in. We're going to be using it a lot today. All right, so I'm going to put it in parentheses. Since it's 2/3, you've got to tell your calculator that 2/3 is connected. It is 2 divided by 3. That is 2/3. So do 2 divided by 3, 2/3, and then plus 5/2, right? Yeah. So parentheses 5 divided by 2. That's the same thing as 5/2. Then I hit enter, and it's going to give me a decimal. Now, we don't like decimals in this class. We're more advanced than that. We're going to push you to rewrite it in the most simplified fraction. So your calculator will do it for you. If you hit this math key right here, everybody, the math key, I hit math, and then I hit enter, because I'm putting it into a fraction. So enter, I hit enter again. It's going to put it in the simplified fraction for me. It'll simplify it down, 19/6. So if I added those up, we'd get 19/6. We're going to need that today. Questions on how to use a calculator. Okay, now on this next part, let's go ahead and multiply these. It's super important you put things in parentheses. So we're doing 2/3 times by -5/2. Now, with multiplying fractions, it's easier because you can multiply straight across. So we will get -10 over what? -10, multiply straight across. When you're multiplying fractions, you don't have to have a common denominator. So -10 over 6, which would simplify to be, what do they both divide by?
-5.
They both divide by 2, so this would be a -5, and this would be a 3. Now let's do it with our calculator so that we don't make any errors with simplification, because we're going to have bigger things than that. So type in quickly here. So parentheses, 2 divided by 3. You should practice so that because it's way different just watching than just actually doing. So then I don't have to write multiplied, because if I write the parentheses right next to each other, that means multiplication. Your calculator knows that. And then -5/2. -5 divided by 2. I I hit enter, it's going to give me the decimal. We're going to change it back to a fraction, so I hit math, enter, enter, and it's negative 5/3, which is what we got by hand as well. Awesome. So negative 5/3. Okay, we're going to use our calculators hopefully a lot with doing these just to make sure we don't get anything wrong. Okay, let's go on. Okay, so today what we're going to do is now this is the whole point. We have learned properties of exponents, and our goal in the core, it says those students have to be able to take properties of exponents and apply them to rational exponents. So today we're going to be doing more properties of exponents, but now with rational exponents. So most of you are saying, because even I did at your age, you're like, what's rational? What do you mean by rational? So I'm about to tell you. In the future, in the rest of this class, if you ever see the word rational, guys, it just means fraction. Good. Awesome. Very good. So some of you know. So rational exponents just means we're going to have fractions as exponents. But we're not scared of fractions, and now that we have these schmancy calculators, it does all the work for us, so we don't need to be scared. As long as we know our properties of exponents, we're good. So once again, looking at this, we have this base x raised to the 1/2 power. It's a rational exponent because it's a fractional exponent. And then this is another example of some fraction exponents. X to the 3/4 times by y to the negative 2/3, also fractional exponents. These are just examples of fractional exponents. So we'll get to our first example here. Okay, so first of all, though, we know all the properties of exponents. We know every single one. You won't ever have to learn another one. You know them all. We know that any base raised to the 0 power, the whole thing becomes a 1. So any base raised to the 0 power is equal to 1. And we know we can take a negative exponent. And when our final answers, we don't write negative exponents. So we can take our negative exponent, we can draw a line, grab it, and flip it over a fraction, such as this, and it's going to make it a positive exponent. So we just flip it over a fraction, and it makes it a positive exponent. We've also learned this. Any base multiplied to the same base, you can combine them by adding the exponents, n plus n. And then we've learned if you have the same base and you're dividing them, then you'll subtract the exponents. Always the top minus the bottom, also very important. And then we've learned on Friday that any base raised to a power, then raised to another power, a power to a power, and you multiply. So we'll multiply the powers on that. So then the song went like this, guys. I assumed you knew the 0 and the negative, so I say, when you multiply, you add. When you divide, then you subtract. Raise a power to a power, and you multiply. So that only works for the same base, and we're talking exponents. It doesn't work for numbers, right? Numbers, if you divide them, you divide them. Numbers, if you multiply them, you multiply them. The only thing that works is exponents and the same base. Okay, let's do our first example. Okay? Not different than anything we've seen so far. The only difference is these fractional exponents. So we have 2x to the 1/2 power times 3x to the 2/3 power. Once again, 2x to the 1/2 power times 3x to the 2/3 power. So we're multiplying all these things. Now we know at this point you can rewrite this in any order. So I'm going to put my numbers by each other. 2 times 3 times x to the 1/2 times x to the 2/3. Everybody okay with that? And then you say, what property of exponent am I using here? Well, I'm multiplying the same base, so I add the exponents. But it's only if you have the same base. So with numbers, you'll just multiply the numbers. 2 times 3 is 6. Good. Now right here, we're multiplying the same base, so we're going to add our exponents. So that's going to be x to the 1/2 plus 2/3. Now that shouldn't look scary to you because you can go off to the side and do it by hand, or I suggest just using your calculator. So in your calculator, type in 1/2 plus 2/3, and I would use parentheses around those. Everybody do it so you can help me so we can get to this way quicker. What was it? Sorry?
7, 6.
So 7, 6. So 6x to the 7, 6. Not 6, 7, 7, 6. Okay. Did everybody get that? Did everybody get that? I'm going with what you say. So, okay. All right. Next example. Any questions on that? Next example. Negative 2x times negative 3x to the negative 4. Once again, if you look at this, guys, we're just multiplying all these things. We don't see any addition signs in here, just multiplying. So we can reorder this one in any order. I'm going to put my numbers by each other. Negative 2 times negative 3 times x to the negative 4/3. Then you look at it and sing your song if you need to. When you multiply the same base, you add your exponents. When you multiply, you add. It doesn't work for numbers, so carefully. -2 times -3. +6. But right here, we're multiplying the same base, so we'll add our exponents. So we'll have x to the, well, what's the exponent on x?
1.
Good, you guys are seeing that. So we'll have 1 plus -4/3.
-1/3.
Okay, good. So you did that on your calculator, and you got
-1/3.
-1/3. So we have x to the -1/3 when you do that on your calculator. All right, now this time we guys, well, do we have questions? Sorry, get going too fast. Are we okay with that, everybody? Okay, so now we need to flip negative exponents. So anything with a negative exponent, now 6 does not have a negative exponent. It has a positive exponent. The exponent's 1. That's got to stay where it is. We've got to grab this and flip it over a fraction. So just don't forget there's really a fraction there. And we're going to grab this and flip it over a fraction since it has a negative exponent. So it's going to become x to the positive 1/3. Now don't forget when you do that, it's gone up here. So I'm going to go off to the side and write this a little bit prettier. That leaves me with 6 on top and then x to the positive 1/3 on the bottom. Questions on that? Are you sure? Okay, let's do another one. Couple more, then I'm going to set you free to work. Couple more, just a couple more, stay with me. Okay, so we have 2x to the 1/2 divided by 4x to the -3/2. Now once again, you can sing your song, when you multiply, you add. When you divide, then you subtract. And we know we always subtract the top from the bottom, but that doesn't work for numbers. Numbers, you're just going to divide. So we have 2/4. Be careful when you simplify that. What does that become? 2 divided by 4. What does it become? 1/2. Good. They both divide by 2, yes, so that becomes a 1. That becomes a 2. 1/2. So just be careful with those guys, because a lot of people still unaccidentally float the 2 up to the top. Okay, so then with the x's, we take the same base and we're dividing, so we subtract the exponents. You always subtract the top from the bottom. So before you even look at the bottom, write the top, write x to the 1/2, then write minus, and then look at the bottom. Oh, the bottom is -3/2. Does everybody see why I did that, so I don't make any sign errors? I did the top minus, and then I looked at the bottom, and I saw it was -3/2. Is everybody okay with that? All right, so when you minus a negative, what happens? Cross the line, change the sign. So that's really saying 1/2 plus +3/2. So what we really have is this right now. X to the 1/2 plus 3/2. Okay, so then you added those together and you got what? 2. All right, that makes sense. So we have 1/2 and then we have x to the 2. Do we need to fix any negative exponents? No, we're all good, right? Now I'm just going to push you in this class to realize that 1 times anything is just itself, right? So we have 1 times x to the 2nd power, which is just x to the 2nd power. And then so we have x to the 2nd power over 2. So you don't have to write your 1 there. Now I would just go one more step and don't write the 1. Questions on that one? Okay, awesome. Almost there, guys. You're doing really good. A little bit harder one. 3x times x to the 3/2 divided by 5x squared. Now there are so many ways to simplify this one, and I don't want to confuse anyone, so I decided to go about it one way. But there's so many ways. So you might do it a little bit different than me, because there's so many ways to simplify this. But what I like to do, guys, is I like to just go ahead and focus on the top and simplify the top, then simplify the bottom, and then simplify the whole thing. So let's just focus on the top for a second. When you multiply, you add the exponents. So we're going to have 3x to the, what's 1 plus 3/2? On your calculator, and we'll simplify for someone. 1 plus 3/2. 5/2, okay? So 5/2. And on bottom, we have 5x squared. Does everybody see what I did there? I added those 2 together so that I simplified the top. Is everybody okay with that? Because this one was trickier. Now we can go through and simplify the whole thing. 3/5, that doesn't simplify any further, true? Leave them where they are. And then now we have, when you divide the same base, you'll subtract the exponents. You've got to subtract the top minus, and then look at the bottom. So we have x to the 5/2 minus, now I look at the bottom, and the bottom is 2. So 5/2 minus 2. So once again, I'm showing all my work. What is 5/2 minus 2? I would just do it on a calculator and then put it in the most simplified. What is it? 1/2. Okay, good. And then do we need to fix any negative exponents? No. No, we're done. Questions on that one? We're almost done, guys, I promise. And then I'm going to set you free to work for a while, and then I'll bring you back to me later. Okay, stay with me for these last two examples. So we have x to the negative 1, x to the negative 2, y to the 4/3, all raised to the negative 1 power. Once again, x to the negative 2, y to the 4/3, all raised to the negative 1 power. So let's sing our song. When you multiply, you add. When you divide, then you subtract. Raise a power to a power, and you multiply. Okay, so with this one, we're going to be raising a power to a power, a power to a power. So we're going to multiply those powers. So we have negative 1 times negative 2. So we're going to have x to the, what's negative 1 times negative 2? Positive 2, good. And then we're going to have negative 1 times by 4/3. So we'll have y to the negative 4/3. Good. Yes, good. Now we need to fix all negative exponents. Well, first of all, just a quick question for you. Can you combine the x and the y's? No, not the same base. Okay. So now we just need to fix our negative exponents. I'm going to draw my fraction. We're grabbing that, flipping it over a fraction. So it'll be y to the positive 4/3 on bottom. Now, I'm not going to write that up there anymore. But I'm going to go off the side because I'm a perfectionist and I would like to see you write it in the prettiest answer without the scribbles. So we have x squared over y to the 4/3. Not too bad, right? Not too bad. Questions on that one? Last example, then I'm going to let you work for quite a while. So stay with me on this last one. It will be worth it to you. Any questions on that? Please ask if you do. Okay, last one. So we have a to the negative 1/2, b to the 3/4, all raised, since it's all in parentheses, all raised to the negative 4/5. I'll let you get that down. I'll read it again. A to the negative 1/2, b to the 3/4, all raised to the negative 4/5. Now we're raising a power to a power, and a power to a power again. So you multiply. So now we've got to go ahead and distribute that through. So we'll have a to the, now on your calculator, I'm going to just write this out. We're doing negative 1/2 times negative 4/5. So I'm going to have a to the what? I'm focusing on a for a second. You should all be practicing. 2/5, good. Positive 2/5, very good. And then we're going to now do our b part here. I'll change colors, why not? So we have raise the power to a power and you multiply. So we have b to the 3/4 times negative 4/5. So b to the good, negative 3/5. Now we look at it and say, do we need to simplify anything else? We fix negative exponents. Anything with a negative exponent, anything else needs to stay where it was. If it was on bottom, leave it alone. If it was on top, leave it alone. Well, we need to fix this. It's a negative exponent, so we're going to flip it over a fraction, bring it down. It's now positive when you bring it down. Don't write a negative again. It's gone now. So writing it pretty like a to the 2/5 divided by b to the 3/5. This would be my simplified answer. Okay, so really, guys, now that we've taken this kind of slow, we've done properties of exponents, you guys are actually really quite good at it. Don't let anything scare you. Nothing can scare you. You know your properties of exponents. Just apply them. Use your calculators. Okay. Any questions on this one? Okay. Then work on 1 through 10 on the worksheet on the front. 1 through 10 on the front of the worksheet. Ready, set, go. Ready, set, go. As you go through, I'll come around and check them. History class. Just kidding. That's a joke. Okay. That was just a joke, by the way. I don't want the history teachers pounding on my door. Okay, guys. So now we're going to talk domain and range. You should have seen this in secondary math 1 at least briefly, but then if not, it's fine because I'm treating it today like you've never learned it before, because even my secondary 3 kids, it was like they had never seen it before. So we're going to talk domain and range today of functions. I promise you guys, this is so important. A lot of you, some of you are going to be taking the ACT this year. Very good chance you'll see domain and range on there. You will see it on the end-level test. A huge part of the core. It's awesome though. Domain and range is really fun, and you'll see it next year in secondary 3. So this is something that you need to keep with you forever. And I actually am really good. Domain and range can be really hard for a lot of students, but I'm actually quite good at explaining it. So it shouldn't be too bad for you. Okay, it shouldn't be too bad for you. As long as you listen to the little details, okay? So domain, guys, this is where you'll want to take notes for sure. So domain is the input values, meaning the x values. So think about a function, guys. Functions are in the form y equals some function involving x. So you'll have y equals, like, for example, like 2x plus 3. That's just an example of a function. So the x, the domain, is the x value. It's the input, what you would plug into the function. And then now when we're talking domain, we have to shift our eyes and we have to only look left and right. It doesn't matter how far up and down the graph's going. We're going to look at our eyes and say, what's our function doing from left to right? So domain, that's the most important part. You'll hear me say that. It's left and right. X values. Domain is x values. You're going to look with your eyeballs left and right. That's it. Left and right. And then range is the output values, what you're going to get out of the function once you plug in some x values. Now, once again, range is the y value, so you'll have to shift your eyes. You're only going to look up and down with range. So this is the way important part. With your eyes, you've got to shift them and say, I'm not looking left and right anymore. Now I'm looking up and down. That's it. Up and down for range. So domain is left and right, our x values, and range is up and down, our y values. So if we get good, and I think we should get good at, you just have to shift your brain. You're like, okay, I'm looking at domain. I'm looking left and right. It does not matter how far up and down. I'm talking left and right. And then when we switch to range, you have to say, my eyeballs are looking up and down. I don't care how far left and right at all. It doesn't matter. I'm looking up and down. If you can say that to yourself, I even have to say that to myself sometimes. Okay, it doesn't matter how far this or that. Like, I just got to focus on what I'm looking at piece by piece. It really helps. So let's do our first example here. Do you guys all have this down about? Super important to have down. Okay, I'll let you finish up getting that down really quick. And then we'll do our first example. Okay, guys, super important. Here we go. So we're going to be given the picture of a function this time and asked to find the domain and range. So looking at this function, we're going to find domain and range. So if you want to draw a rough graph, but mostly looking up here is going to help you the most for this part. So domain is left and right, x values, left and right. So you have to shift your eyeballs, guys. I don't care how far up and down. I don't even care that this function's going up. It doesn't even matter for domain. I'm talking that way and this way. What's our function doing? Now keep in mind before you answer this. Keep in mind, here's my x and y axis. Does everybody understand that? Okay? Now in the x direction, if you just keep growing this way forever and ever, it's going to approach infinity, right? Okay? Now we can't, infinity is actually really cool because you can't peg it as a number. Infinity is not a number, it's like a place, a thing. So it's kind of cool because we can't really, our human brains cannot wrap our minds around what infinity really means. And it's not an actual number, it's a place. So does everybody understand though, as it gets larger and larger that way, it's going to infinity. Yeah, you all okay with that? And as our x's grow backwards this way, we're growing to negative infinity. We're getting really, really small. Does that make sense, everybody? And then for on our y-axis, up here on our y-axis, if we get really, really large up there, we're growing towards infinity. And then down here, we're growing towards negative infinity. Okay, so back to domain. Now we're talking left and right. We're stating what our function's doing from left to right. I do not care that it's growing up. Doesn't matter. I promise you, for domain, it does not matter that this function's growing up. I'm asking you, where's my function growing that way and that way? Let's start this way. Where's my function growing? Not up. I'm talking this way. Where's my function growing this way? Where's it growing towards? Good. Negative infinity. Does everybody see? I don't care that it's growing up. I'm talking this way. It's growing this way towards negative infinity. Does everybody see it? Okay. Now from left to right. So right. Where's my function? I don't care that it's growing up. I'm talking domain and range. Domain is right. Right and left. Left and right. So where's it growing that way? Positive infinity. So it's growing from negative infinity to positive infinity. On the left, it's growing towards negative infinity. On the right, it's growing towards positive infinity. Now, infinity, since we can't peg it as a number, gets parentheses because we can't call infinity an actual number. So keep that in mind. Okay, does everybody see how this function's growing negative infinity and positive infinity on those? Okay, now shift your eyes. Super important. Shift your eyes. Now I'm talking range. Now I am talking up and down. I don't care if it's growing that way and that way. I don't give a crap for range. I'm talking up and down. Where's my function growing from? So let's start. Where does my function start? At what value? Starts at -3 and it's growing to, where's it growing? Up and down. Up, it's growing to positive infinity. Okay, good. So now, did it include 3? Did it land right on 3? Yes. So to say it includes 3, you put a bracket. Bracket means it included. Parenthesis means not included. So infinity is not a number, it's a place. So you just got to put a parenthesis around infinity. Okay. Range. Does everybody see how it started at -3 and grew to positive infinity on our range? Yes.
So if it doesn't touch it, like it's not touching like the infinity where it grows up, and there's not a number that it's touching, so would you just put infinity?
You put infinity, yes, because it is getting larger and larger, growing towards infinity, which just means it's getting larger and larger and larger, infinitely larger. Great question. Great question. Yes.
Why is that you have to put the included in front of that?
Because this function touched down right at 3. There's not a hole in the function, and we'll do an example where it doesn't touch down. But then you see how it starts right at 3. So that means it included 3. It started on -3. So the bracket says, I know it started right on -3. If it would have been an open circle right there, it would have put a parenthesis to say it didn't land on -3, but it starts at -3 still, yeah.
So anyway, -3, would you still have the bracket but on the other side?
Let's do some more examples and we'll see something like that. Yeah, let's do some more examples and you'll see more of what we're looking at here. So let's look at this one, guys. Next one. So we're talking domain and range of this function now. Now, once again, you have to get good at shifting your eyeballs and thinking in your head, okay, we got to think correctly here. So domain is left and right. I do not care at all with domain if my function's growing up or down. Doesn't matter. Does not matter. I'm talking left and right. So looking at my function, it doesn't matter if it's going down. I'm talking left and right. Where is my function growing? This way. Good, negative infinity. And now, where's it growing that way? Positive infinity. Do you have questions on that? If you do, ask. It doesn't matter that it's growing down. I'm talking domain. I'm talking where's it growing? This way and that way. Does that make sense, everybody? Now, infinity, once again, is a place, not a number. So I'm going to put parentheses around it just because we can't peg infinity as a number. Yes.
Okay, so as long as it's not landed, like the lines on an exact number, you would just put infinity?
Yeah, because see how it's growing and it has these arrows saying it's going, okay, sorry, so this is domain, right? So it's going that way for forever and that way for forever. Just continuing to grow. Ooh. Yeah. Does that make sense? Okay. Okay, well now let's shift our eyeballs, guys. Range is up and down. I do not care that it's growing this way and this way now. Now my eyeballs have got to shift. Where is this growing up and down? So let's look at this function. Where did it start? 8, and then it was growing to negative infinity. Now which one's smaller, negative infinity or 8? What's smaller, guys? Negative infinity or 8? Negative infinity is teeny. So negative infinity, we've got to write first. You always write the smallest number first. So it's going from negative infinity and it stops at 8. Did it include 8? Did it land right on 8?
Yes.
Yeah, so we put a bracket around 8, and then infinity, we always put a parenthesis because we can't peg it as a number. Do you see how it starts at 8 and grows to negative infinity? Now it's correct in proper math to write the smallest one first. Negative infinity is smaller than 8. Okay, questions on that? If you do, you guys, domain and range is really hard for students at first to see. So if you're having a hard time, please ask, like, explain that again, explain that again. All my other students that I've taught every other year have said, wait, now what? Why is it that? And you guys aren't concerned. Either I'm teaching it really good or you don't understand it and you don't dare ask. So please ask. Okay, let's do another one. Okay, let's do another one. So now we're talking domain and range of this one. Domain and range of this one. So now you got to shift your eyes again. I'm talking left and right. It doesn't matter if my function with domain, does not matter if my function is growing up or down. Does not matter. I'm talking left and right. Where's my function starting and growing to? Okay, so looking at this one, left and right. Boom, where does it start? Left and right, not up and down. Left and right, where's my function start? Negative 3. Negative 3 right there. So it's starting at negative 3. Good. And then it's growing that way where? Positive infinity. Did it start on negative 3? It did, but it didn't include negative 3. So this is where we would put a parenthesis. Since it's an open circle, it didn't fill it in at negative 3. It didn't land right on negative 3. But it did start at negative 3. So we put a parenthesis saying not including, starting at negative 3, not including. And then infinity always gets a parenthesis. Questions on the domain on that one, guys? Please ask if you do. It's okay. Other people don't understand if you don't. Okay, so then range. Now you have to shift your eyes. I don't care where it starts from left or right. I don't care at all. I'm talking up and down. That's it. Up and down. So let's see, right here, up and down. Where does my function start? Up and down. It doesn't matter how far left and right, up and down. Good, positive 1. So it's starting at positive 1, and then it's growing this way to positive infinity. You're awesome. Did it include positive 1?
No.
Didn't include it, so we got to put a parenthesis, and then a parenthesis around infinity. Okay, let's just do a couple more, and then I'm going to let you practice these on your own. Couple more. Stay with me, people. Okay, finding the domain and range. Finding the domain and range. Shift your eyes. Domain is left and right. I don't care if it's going up or down. Don't care. Left and right. So looking to the left, where's my function growing? It's growing this way to negative infinity. Good. And then where's it growing to the right? Positive infinity. Very good. Did not matter that it was growing up. We're not talking up and down at all with domain. We're talking left and right. Questions on that one? Okay, let's now shift our eyeballs again. Now we're talking range. Up and down. Where's my function going? Up and down.
Negative and positive infinity.
Good. It's going to negative infinity and it's going to positive infinity. Questions on that? Please, 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 please. I'm begging you to ask if you're not understanding that. Okay. Okay, couple more. Okay, domain and range of this craziness here. Domain and range of this crazy one. Now don't let it scare you guys. Your eyeballs are going to shift and you're just going to look at it and determine what we're looking at here. So domain is x values. I don't care that this is strung out up and down. Don't even care at all. I'm talking left and right only. That's it. For domain, left and right, that's all that matters. So from left to right, where's my function starting? Good, negative 10. Did it include negative 10?
No.
Didn't include negative 10, so I'm going to put a parenthesis. And then it grew to this way. Positive what?
4.
Positive, I think it's kind of hard to tell. Yeah, 5. Did it include positive 5?
No.
Yes.
Was it a closed circle?
Yes.
Yes. So it included positive 5. Does everybody see how it didn't matter up and down for domain? Did not matter at all. Does everybody see that? Left and right, it went from negative 10 to positive 5. Now shift your eyes. Now it doesn't matter that there was a wall here and here. We're talking up and down. Shift your eyes. Where's my function going from down to up? Starts at negative 8. Did it include negative 8?
No.
No, it was an open circle. Good. It started at negative 8. Didn't include it. And then it grew up to what number? Positive 4. Did it include positive 4? Yes, so bracket. Okay, questions on that one? Okay, last thing, I want to make a point. I don't have an example like this, so I just want to say it because I was noticing on the worksheet that I provided for you that it was a little bit confusing. Now, does everybody understand this? Let's say I want to change this. Sorry, I'm going to sneeze. Okay. Let's say I would have taken this blue graph and went like this and went above that line and then came back down. Let's change our range on this one. That's not our range, is our y values are up and down. Well, this time, even though there's a dot here, it grew up to what point? Positive 8. So if that would have been the case, our range would have been from negative 8 to positive 8. Does that make sense?
Yeah.
So if it bounces up there and comes back down, it doesn't always go to the ends. Does that make sense? Look left and right. Where's my function going from left and right? That's it. Then look, where's my function going from up and down? Okay, so I feel confident that you guys can practice the back of the worksheet. Ready, set, go. I'm going to be coming around as you do a few. Have me come check them. Domain and range is hard at first for students. Shift your eyeballs, guys. Shift your eyeballs around.